Hi, welcome back to the channel, and today we're going to continue on with our video series on the Apple II computer. What we've been focusing on in the last few videos are the storage devices. So I'm talking about the Disk II system that came out in 1977. I have a timeline where I showed you all of the different storage solutions that came out during the lifetime of the Apple II. What we're focusing on today is the UniDisk and ProDOS era. So in the timeline video, which is definitely worth watching, I talked about this drive here. This is called the DuoDisk, and it's an absolute beast of a thing. And it's actually two what would become to be called UniDisk disk drive, 5¼ inch drives. With this plugged in, obviously you would have a very capable Apple II. About a year later, after this was released, Apple released a single drive version of this, which is called the UniDisk 5¼ inch. This one has a 19-pin D sub, plugs into a new card, an IO controller card, which was introduced with a DuoDisk. And you find these days these are very easy to come by and are very reliable units. So this is actually what we're going to be using today in our guide and tutorial to actually try it using ProDOS. What we're not going to look at today are the 3½ inch drives. So this is an example of this. And that's because these are less used on the Apple II series, not so much the 2GS. This was actually the standard drive on the 2GS, so definitely used there. But this is also a drive from what I would call the ProDOS era. Obviously larger capacity, 800K per disk. But because the 5¼ inch drives were standard really from about 1978 onwards with the Apple II, companies carried on producing disks in that format. And for that reason, this wasn't really adopted on the sort of classic Apple II line. I'm talking about the Apple II Plus, the Apple IIe, Apple IIc and so on. Until of course the Apple IIc Plus came out with one of these built in. So yeah, then that would have used these more, I guess. So anyway, yeah, what we're going to look at today is the UniDisk 5¼ inch. And we're also going to look at ProDOS, because it does have some differences from the previous DOS released by Apple, Apple DOS. We have a great deal to go through today, so let's move on pretty quickly and take a look at our first piece of hardware, the DuoDisk. So the first piece of hardware we're actually going to look at is this one here. This is the DuoDisk, and I'm not going to hold it up to the camera for very long because it's actually pretty heavy. Let me just turn it around for you. As you can see, obviously it's got two disk drives at the front. That's pretty clear. And they are just sort of standard, basically disk II drives inside a new enclosure. So there's no problem with incompatibility or anything like that. On the back of the unit, you can see here on the left-hand side, there is a connector here. It's a little bit difficult to see there in the shade. It's a 25-pin connector, and that means you have to have a special custom cable to connect this up to the Apple IIe, because on the Apple IIe side, the custom card that comes with this, which is called the IO card, or I think later the 5.2 card, actually has a 19-pin connector. So let's get a little bit closer to the machine and we'll install this. And unfortunately, I can't actually show you it working because this drive has a failure. And I actually have another one of these, and that actually has a failure as well. The kind that smells very badly electrical. So yeah, something is blown in this drive and in the other one. So at some point in the future, I'm going to have to get around to fixing these. But yeah, let's get in there and have set this up. Okay, well, this is the DuoDisk drive, and it's a slightly sort of monolithic design. I don't think it comes from the exact same design school as the original Apple II did back in 77 when it was designed originally. This looks slightly more modern. I think it actually came out of the design language which they developed for the Apple III. It's possible maybe that this was intended to be some kind of product related to the Apple III originally, but eventually, as we know, it became available for the Apple II. This is the controller card for it. I'll show you that here. And you can tell it's an original one because it says IO controller here. They changed the name a little bit later when the UniDisk drives came out a couple of
well, a short while after the DuoDisk actually came out. This obviously has to plug into your Apple II. This comes out of the back of the Apple II. It's a 19-pin D-sub connector. So we'll be connecting that up with a custom cable that we have here, and then it goes into the back of the DuoDisk on this side actually. So let me put this in. I'm not going to actually fully install this because there is actually a nut on it here, which I'll show you. That has to come off. You then put it through the back of the machine with this protruding, and then you screw these nuts in to hold it in place. And that's a little bit fiddly to show on camera, and there's not real need for that. So what I'm going to do is I'm just going to plug it in here, and we'll leave the cable inside. So yeah, this would go through here, and then we would attach the nuts on the back. So for instance, if we were going to install it in slot 6, I would push it in here. There we are. This is non-detachable, by the way, so this is the only way you can install this. Put it there, and then attach it with the nuts. Once you've done that, you have a nice 19-pin D-sub on the back of your machine, which is really way better than the two 20-pin connectors you had on the original Disk 2, are very much prone to causing damage to the drive when you plug things in backwards. So once that's in, you can actually put the lid back on the machine. So I'm going to just do that. There we are. And then we can connect our cable to this. So I'm going to just put this in the back of the machine. Make sure I get it the right way around. There we go. This can then sit on top of the machine. This is what it's designed to do. There we are. And then this, obviously, this cable would then plug into the back of our card at the back of the machine. And that would give you a slightly later tower of power. Definitely a very nice design, I think. It goes together really well with the Apple II. This unit was actually retro-brighted by myself. When I received it, it was quite badly scuffed and dirty and so on and so forth. So I had to do some renovation work on it. As I said, right now it's not actually working. So in the future, I will definitely get this working, and it'd be really good to get it in use with this machine. One of the limitations of this actually is that it doesn't have another port on the back, so you can daisy chain any of these together. So basically, you can only have two of these drives, two drives attached to the one card at the back here. But if you wanted to, you could do this, I suppose, and buy another card and plug it into another port. And then you could have a slightly ridiculous super tower of power, as you can see here. But yeah, so yeah, these drives, like I said, neither of these two is actually functional. So we're not going to be featuring these working, unfortunately, in this video. But don't worry, I do have some UniDisk drives, which are based on exactly the same technology. And let me show you getting one of those set up next. This is a UniDisk drive, and as you can see, it's very, very similar in its styling to the DuoDisk. Definitely comes from the same family of drives, obviously. And on the back, there is a slight difference. Well, actually, there are a couple of important differences. Number one, the cable that goes into this is fixed. You cannot remove it. And it makes sense why that is the case, and I'll explain that in a second. And here you see you have a port on the back, and that allows you to actually connect another one of these drives into this. So I can do this here with this cable. Obviously, you wouldn't want to do this in reality, but you can basically plug this in here. So imagine this was a different drive, and now we can have a second drive daisy chaining off this one. So this connects to the same card as the DuoDisk. It is completely compatible. As I said in the video earlier, they did actually release the card again when this drive came out, and they gave it a slightly different name. But as far as I can tell, electronically, it's exactly the same. So if you want to buy one of these drives, you can buy either of those cards, and it should work perfectly fine with this. So with that said, let's actually get this installed ready for our tutorial part of the video, where I'm going to run you through ProDOS. So let's pop this on the table here. And I'm not actually going to connect the cards DB19 out of the back of the machine. I'm just going to hang it over the side. And that's because it just makes it easier for me to remove it if I want to during this tutorial. So let's take the lid off. We'll pop this over here. And here we have the connector. And all I have to do is obviously plug this into this. There we go. And now we'll put this cable over here out the way. Here we are. Next, I'm going to bring over another one of these drives. There it is. That's our second drive. So obviously this is functionally pretty much equivalent, I guess, to having one of those DuoDisk drives, except you've got a bit of a cable, an extra cable coming out of the back of this one. Let's put that back in. And as we did in the last video, I'm going to use one of these as well. Let me get this here. This is a floppy emu by Big Mess of Wires. It's a floppy disk emulator, and it will emulate many different types of floppies. It will actually emulate a 3.5-inch Apple II floppy, as we discussed earlier. It will also emulate hard drives as well. So if your machine is capable of actually interfacing with hard drives, as this one is, this is an enhanced 2E, then you can actually mount hard drives, which is pretty cool. This is just one of the older Disk 2 cards, but this is basically the same as this card here. It's just really a reworking the new card. So they are functionally equivalent. The only real difference is that this one has the 20-pin connectors and the other one has the DB19 connectors, which are, to be fair, quite superior because, well, it's just a neater, more modern solution, which they just didn't have, I guess, back in 1978. So let's get this plugged in, and then we can use this during this video to show you having 3 ProDOS volumes mounted at the same time. So yeah, let me just do that. So I've got this in slot 6. This is for the 2 UniDisks here. And I'm going to just plug this here in slot number 5. And because of the architecture of the Apple II, all 3 of those drives and their volumes will be accessible to me, which is pretty cool. Let's just pop that there. So yeah, we're just going to leave the case open like this. We now have 2 5.25-inch drives, functionally basically equivalent to the Disk 2 drives. And we also have a floppy emu here, so we can experiment around with that as well. It'll be quite nice to show one of the strengths of ProDOS, its ability to use different name volumes. So yeah, let's have a look at ProDOS next. ProDOS, or to give it its final name, ProDOS 8, is the last official Apple operating system usable by the 8-bit Apple II computer range and was distributed from 1983 to 1993. ProDOS was intended to replace the original Apple DOS, which had been released with the Disk 2 system some 5 years earlier in 1978. From an Apple II perspective, Apple DOS was looking somewhat limited by 1979. When Apple DOS was designed, it had a limited scope. It was intended for use solely on the Disk 2 drives. But in 1979, Corvus launched the first hard disk aimed at the rapidly growing microcomputing market, and the Apple II was lucky enough to be supported. The only issue was, its only DOS, Apple DOS, had no support for a volume as large as 10 megabytes, which the Corvus provided. As a result, the Corvus drives had to use a patched version of Apple DOS to accommodate their much larger volume size. Another issue was that Apple DOS only supported a flat hierarchy, so it was not possible to make even a single-level subfolder. With a 100 kilobyte floppy disk, this was not that much of an issue. It really could not hold enough data to really make folders a must feature. But of course, with the Corvus supplying a single 10 megabyte volume, this was now shown to be a pretty massive limitation of the DOS. The Corvus drive had put a spotlight on Apple DOS and shown it was not fit for purpose on these new, much larger drives. In 1978, Apple launched a new project to create what they hoped would be a more capable replacement for the Apple II. Originally, Apple assumed the Apple II would sell mainly to an enthusiast market, the kind of people who had hand-built an Apple I. But it had turned out to be a massively more successful computer than they expected. It appealed to many more users, and many of those were small businesses. There were some pretty glaring issues with the Apple II, though, in terms of business use. It did not really have enough RAM, its CPU was not really that fast, and its floppy disk system had limitations, as we've just discussed. But the Apple III was designed to address all of these issues. The Apple III was aimed squarely at business users, and Apple's plan was that when it was released, existing Apple II business users would sell their Apple IIs and upgrade to an Apple III, and that would be that. So it needed to fix all of the Apple II's limitations, and that included its DOS. A new DOS was developed for the Apple III called the Sophisticated Operating System, or Apple SOS, or as it was more commonly called, Apple Source. Applesauce was designed to be a much more sophisticated OS, as it mentioned in its name. Applesauce was designed from the ground up to support much larger volume sizes, and also multi-level subdirectories would also feature. When the Apple III was released in 1980, it was heralded as a new dawn for Apple customers. The machine shipped with a 2 MHz 6502 running at roughly twice the speed of an Apple II, and it also had an upper memory limit of 512 kilobytes, despite the fact that a 6502 CPU can only inherently address 64 kilobytes of RAM. Ultimately though, the Apple III was a failure in the marketplace, and this was mainly because of a combination of its very high price and also its very poor reliability. On launch, it cost $4,340, which is the equivalent of, get this, £17,107 in 2025. The cost was one thing, but the very poor reliability must have really hampered sales, of course. And when the IBM 5150, the first of the IBM PC line, was launched under a year later, costing around $3,000 for a usable machine, the writing really was on the wall for the Apple III. So even with a head start, Apple struggled to rectify these issues. Basically, the damage was already done. But its Applesauce operating system held a number of new technologies that could help transform an Apple II's use. So, as it began to transpire that the Apple III was not a sure bet for the future of the company, moves were made to leverage some of the technologies developed for the machine for its smaller brother, the Apple II. One such technology was the use of bank switching to allow the machine to use more than 64 kilobytes of RAM. This was adapted for use in the Apple IIe, giving that machine a ceiling of 128 kilobytes of RAM, although it came with 64 kilobytes as standard. And this technique went on by third-party manufacturers to supply RAM solutions for the Apple II all the way up to 1 megabyte in size. Another project that Apple undertook was to create a new OS for the Apple II based on Applesauce. This new DOS was to be branded ProDOS, the Professional Disk Operating System. The new cost-reduced Apple IIe project was slated to make use of this new DOS, though it could still happily use Apple DOS, as all of the changes in ProDOS were in the software, not requiring any changes to the disk drives themselves, which of course was a real boon to both Apple and the end users out there. When the IIe was launched in January of 1983, ProDOS was not quite ready, so it came with Apple DOS at first. Later that year, in October 1983, ProDOS was finally released to developers, at which point the IIe was supplied with Apple DOS and the new ProDOS, whilst ProDOS was also released as a separate product for the Apple II Plus. By early 1984, ProDOS was seen as a solid replacement for Apple DOS, and from then on, new Apple IIs were seen shipping only with ProDOS. ProDOS became the most popular operating system for the Apple II just 10 months after its release. ProDOS requires an Apple IIe, an Apple IIc, or an Apple II Plus with at least 64 kilobytes of RAM to operate on. It does say in the technical manual that it can run with 48 kilobytes of RAM, but it's basically recommended that you don't do that. It's a very poor experience. For Apple DOS users, there were perceived to be some small limitations to ProDOS, which caused a little friction in getting those users to move over. The main issue being that Apple DOS supported file names with a maximum of 30 characters, whilst ProDOS limit is only 15 characters per file. Another change is that in ProDOS, spaces are not allowed in file names, whereas they originally were in Apple DOS. You can only use alphanumeric characters and periods in a name. Despite these minor annoyances, ProDOS offers many more pros than cons, of course, and it soon became the standard OS for users and developers alike. So, what were the main features of ProDOS? Volumes are now named, allowing you to refer to them by these names. In Apple DOS, you could only refer to physical drives by their slot and device numbers, but now with volume names, this allowed you to refer to files on specific volumes, irrespective of the drive that it currently was in. This meant you could take a floppy disk, pop it in a drive, type in the volume name and a file, and it would load. Take that disk out, put it in a completely different drive, do the same, and it would load as well. You could just move the disk around and it didn't matter. Support for hierarchical subdirectories. So now, if ProDOS was used with a hard disk, you could organize your files in a much more efficient and usable manner. This, combined with volume names, made coding file access much easier for developers. And of course, folders could be used on floppy disks just as much as they could be used on hard disks. It was a general feature. ProDOS expands the maximum volume size from 140 kilobytes per volume to 32 megabytes. Obviously, this is a massive uplift, and finally it gave the Apple II a suitable DOS for hard disk use. ProDOS supports RAM disks. On machines with 128 kilobytes or more of system memory, this means you can now copy commonly used files to RAM and then load these from there. I used a RAM disk on my Amiga 1500, and this felt like having an SSD back in an era of slow floppy disks and hard drives. It really was a killer feature. Real-time clocks. With real-time clocks, this means that files can be timestamped when they're created or when they're updated. And this is a commonly needed feature on most modern OSs that we use these days. ProDOS adds a standard method of accessing ROM-based drivers on expansion cards. So now you don't have to have hacky changes to the underlying OS to expand upon it. So as you can see, ProDOS really did feature a large number of major improvements over Apple DOS, and once the new file name format and size limitations were taken on board by users, Apple DOS was clearly no longer viable for most users in general use. But this was not the end of the road for development for ProDOS. In 1986, the Apple IIgs was released, featuring a 16-bit CPU. To support this new 16-bit architecture, a new version of ProDOS was released for the Apple IIgs. To differentiate this new 16-bit DOS from the version for the 8-bit Apple IIs, it was branded as ProDOS 16. Of course, originally ProDOS was released with no postfix in its name, but around the time version 1.2 of the 8-bit version of ProDOS was released, it was renamed to ProDOS 8, making it clear it was intended for use with the original 8-bit Apple IIs. So that's a quick overview of the development of ProDOS. Let's take a practical look now at using it on my Apple IIe here.
But before we do that, let's have a quick word from our sponsor, PCBWay. Ho ho ho, it's that time of year again. PCBWay have their Christmas sale on. Why not pop over to their website right now, where they have purple, matte black and pink solder masks, all as free upgrades. Just scroll down the page because you'll find coupons there. First come, first served. Get them now, get those discounts. So if you need 3D printing, CNC machining, or PCBWay manufacture, why not pop over to PCBWay right now, because
whether it's PCB prototyping, PCB assembly, 3D printing, or even CNC machining, PCBWay is the way. Starting with an instant quote for your PCB projects, PCBWay will leap into action, building your PCB, assembling it for you if you wish, and once it's passed their quality tests, it'll be winging its way to you in a flash. PCBWay, PCB prototyping the easy way. Okay, so let me explain the hardware setup again. I know we set it up earlier, but I just want to explain it again right now so it's familiar. We have two physical disk drives. They are UniDisk 5.25 disk drives. And on top, we've got a floppy EMU. So we've got 3 disk drives plugged into this machine. This bottom drive here is physically plugged into an I/O controller card here using a DB19 cable. And then this drive sitting on top of it is then daisy changed into the back of it, which means it's then effectively plugged into the same card. That is in slot 6. So this is slot 6 device 1, and this is slot 6 device 2. The floppy EMU is using an older disk 2 card here, and it's in slot 5. So this is actually device slot 5, device 1. So yeah, those are the 3 drives that we have there. In this tutorial, we're actually going to use 3 floppy disks to teach ProDOS. We have ProDOS A. This is basically, as it were, a blank ProDOS disk. It does actually have some files on it, which I'm going to use to show you how ProDOS works. But the volume name of this disk is the letter A. It could have been something more complex, but I just wanted to use something nice and short, so it's easier to type names, basically. Then we have another basically blank disk, ProDOS B. This just has a catalog name of B, so we're just going to pop that in there. And we'll pop this down here. So there we go. And then we have a third disk, and this is actually quite an important disk. This is the utilities disk. That came with ProDOS. Obviously, back in the day, this would have been branded with Apple branding, but I'm not going to spend a fortune to buy an original ProDOS disk from back in the day. On top of that, it might not even work anymore. So I found these ProDOS disks they're actually quite new. So
they are currently working reasonably well. Now, I don't have 3 physical disks disk drives, so I'm not going to, swap this around. So what I've done is I've actually loaded up an image of this on here. And in fact, it was this image that was used to originally write this in the first place. So yeah, that's one of the advantages about having, floppy EMU, is that you can easily write disks if you have a floppy EMU and a physical disk, of course. So I'm going to turn on the machine. This is currently the first bootable device because it's in slot 6. We always boot from slot 7, 6, 5, and so on. And it's going to load up the first device, which is this one. So if we turn on the machine, it's going to auto boot off this disk. It's basically a blank disk. So what I'll actually do is I'll just quickly reboot it again, so you can actually see the boot sequence. So there we are, ProDOS 1.01, January 1984, copyright Apple computer, and you're left at a basic prompt. If you've used Apple DOS, you will know that you can get the contents of a disk by typing in catalog, but in ProDOS, they changed that into 2 different commands. There's cat, which is a version of the command which is designed for a 40-column screen, which is what we're using here. And then we have the original command, which is catalog, spelt the American way. And that is for an 80-column display. So let me just show you quickly those 2 working. So we'll type in cat. This is for 40 columns, and it fits really nicely on a 40-column display. If I type in catalog, what you'll find is it actually overflows the screen slightly, so it's a bit of a mess. Yeah, that's a bit of a jumbled mess. So to be able to use that, you need to put the machine into 80-column mode. So I'm going to do that by activating slot number 3, sorry, there we go. That's going to put the machine into 80-column mode. And now if I type in catalog, sorry, cat, we'll get the same 40-column display, but this time on an 80-column screen. So it's not really taking advantage of that extra space. So again, we'll type in catalog, and you'll see now it fits onto the screen quite nicely. There we go. So what you can see is with both of them, you get some extra information compared to what you used to have in Apple DOS. Well, you can see that you've got a file here called ProDOS with an asterisk to the left of it. That means that the file is actually locked, which means you can't delete it. You have to use the command unlock and lock to facilitate that. So we'd have to unlock this file to be able to delete it. ProDOS is one of the 2 ProDOS system files. You can see here it says system. We have a util directory, which actually we're not using this tutorial. That's actually just an empty directory. Then we have the basic.system file. That's an important system file. You can see it says .system there. And then below it, we've got a cats folder, and that's just a folder that we can use to sort of navigate around disks and, just see that there is actually a hierarchy of folders on this disk. So ProDOS is very important, the ProDOS file there. You see 31 blocks. That actually is ProDOS. It's the kernel of the disk operating system. It contains all of the ProDOS commands, load and open files, close files, all that kind of stuff, copy files. It is basically ProDOS. If you don't have that file on a ProDOS disk, it's actually not going to work as it should, because that's used to track basically everything. So yeah, that's a pretty key file. The second file that you have is basic.system. That's actually there to load up BASIC and then to facilitate ProDOS within BASIC. And it's actually what we're using right now. Whenever I type in cat or catalog, that's actually a BASIC command. And obviously it needs the ProDOS file to then make those commands work. So hopefully that makes sense. You can actually have a valid ProDOS disk, as far as I understand it, without basic.system. You can have other files. And I believe that the order of a disk actually determines which .system file gets loaded. So they will basically be loaded when you restart the machine. But on this particular disk, we only have basic.system, so it's just going to look for that and load that up and boot into BASIC for us. So if we wanted to, we could load up this other disk here, disk B, and we'd have a very similar thing. So let's do that. So I'm going to do prefix. Prefix command is basically very similar to changing directory in DOS or Unix or something like that. So if we type in prefix / that means a volume name, and then the name of the volume, which is B, because I've called this B, something nice and simple. You'll see this disk now gets accessed. And if we type in prefix, it will actually tell us what our current prefix is. And the prefix is our current location. So we are now changed our current location to be on this drive here because of that volume. If I type in catalog, you will see we'll get the contents of this disk, which has ProDOS, Basic System, and dogs. The other disk, if you remember, had cats on it. So yeah, got a bit of a cat and dog thing going on here. So using the new prefix system, that's how simple it is to change between different volumes. What's really interesting is that we don't have to rely on the physical location of disks anymore to access data off them. You could quite easily have 10 of these drives plugged into a machine. Wouldn't be very practical, but you could do it, I think, using multiple cards. Yeah, you could probably get eight quite easily. Now, you could have, let's say, a video game where you have your character disk, you have your landscape disk, you have your town disk, and you could pop those in different drives, and you wouldn't actually have to care which ones they were in, because when if the game was written to use ProDOS, it would just request files based on their file names from their specific volumes. Characters / weaponry, let's say, or town, it might be, you know, town /town / buildings / temples, something like that. I don't know. So you actually get this much better, more reliable system, which doesn't rely on physical slots. Now, the prefix, as I said, keeps a track of where you are. So if I wanted to change into the dogs directory, I'd have to change my prefix to that dogs folder. So I would type in prefix. I don't have to type in this particular case, the / because that would say I'm doing a volume name again. I can just do a relative path from where I am, and I can just type in dogs. And that will change my prefix into dogs. There we go. Now, to see what's actually in that directory, I would just type in cat. I'll just use the 40-column version. There we are. So we are now in the dogs directory, which contains breeds, which is another folder, and I love dogs, which is a basic file that I've written. So as you can see, we now have nested folders. We don't have just one level, we have multiple levels, and I'm not quite sure how deep you can go, but I would imagine it's pretty deep. I'll put it up on screen if there is a kind of practical limit. So if I wanted to change into the breeds folder, I would type in prefix breeds. Again, it's a relative change, so you don't have to type /b /dogs /breeds. We can just do that. Type in cat, and we will actually see what the different breeds are. We have brown breeds, barky dogs, toy dogs, yippy dogs, and scratchy dogs. There we go. And they are just basic files as well that I've just created just for this tutorial. Now, there is a little bit of a sort of awkward issue, I think, with ProDOS, which is it makes it quite difficult to go back up directories. If you're used to DOS or Unix and things like that, you're probably forward to having a notation like that to go back up a level, but it doesn't actually exist in ProDOS. So if I wanted to go back up a level to just the dogs folder, I would unfortunately have to type in the full path to it. So I'd have to type in prefix like that, and then what was it, the B drive, and then dogs. There we are. If I type cat, you can see now that we're in the dogs folder. There we go. Yeah, it's just a bit of a pain. I mean, I've had a look around to see if that's actually something which is actually a feature, and I couldn't find that it is. If you know better, then please let me know. It is a bit of a pain to have to constantly type in the full path. There is one silver lining in that respect, which is ProDOS, as far as I understand, keeps a track of the original boot drive, which in this case is A. So if I wanted to go back to my boot drive, all I would have to do is type in prefix / and it should go to A. So if we do that, and then cat, there we are. It's now back on the A drive because we changed our prefix back to the A drive just by typing in prefix / and we can check that just by typing prefix. There we are. It's gone back to the A drive. Now, let's just show you how, you know, the disks don't rely on physical location anymore. So let's catalog this disk. we've got the cats folder on here. So I'm going to prefix into cats. There we are. Let's catalog that directory. We've got breeds in here. Oh, we've got another directory called kittens. So let's prefix into breeds of cats. There we are. We'll catalog that. There we are. We've got pink cats, grey cats, funky cats, smelly cats, and slinky cats. Very nice. So what I'm going to do now is I'm going to swizzle the disks around, and I'm going to do another catalog, and we should see the same result, even though we've actually swapped the disks around, because ProDOS is keeping track of the volume names, not the physical locations that the disks are in. So let's take that out. We'll pop disk A in the top drive, disk B in the bottom drive, and let's type cat again. And now it's looking for the volume. There we are, it's found it. And there we are, it's giving you the catalog of A cat's breeds, because that is now in here, okay? So as an example, what would be the name of this volume? We don't know, okay? So that's a bit of an issue. How do we handle disks which we don't know the volume names of? Let me just put these back the other way around. Not that it matters, to be honest, but anyway, just to make it easier for me mentally. So what we can do is we can change the prefix using slot notation, which is something that's been built into the Apple II since the Disk 2 system came out. So what we can do is we can type in prefix and then comma instead of /. Then the slot, so we use S for slot, slot 5, so this is slot 5. We don't have to type in the device name because there's only one device. So if we type that, there's a bit of a flashing going on there. It's accessing that volume. And now if we type in prefix to see what the prefix is, it tells us that it's ProDOS. So that particular floppy disk has a volume name of ProDOS, okay? So now if we wanted to, we could change back to one of these two disks, and let's say we didn't know what they were either. So let's change to this drive here. So prefix, comma, slot 6, comma, device 2. There we are, it's accessing that. And if we catalog it, there we are, cats. And now this one has dogs on it, doesn't it? So let's prefix that, comma, slot 6, device 1. Catalog that. There we are, we've got dogs. So there you go. You can see that you have this really new, powerful volume system, which allows you to navigate between different volumes. So once you know their names, you can now specify files and folders using specific paths based on volume names. And that means you can write software in a much more organized manner and rely on the fact that you're going to find files on a certain disk based on its volume name, not on which drive it's actually inserted into. You know, one of the issues with earlier games with the Apple II was that if a game wasn't actually inserted into, let's say, the first drive, it wouldn't boot. Or it wouldn't be able to find certain files. Whereas now, you don't have to rely on the fact that it's in a physical location. You can rely on the fact that it has a volume name and you can access the files on that volume using its fully qualified path name. But at the same time, you can see that we still have the physical definitions of drives, and that allows us to access drives based on the actual physical slot and device number. Okay, next, what we're going to take a look at are the main commands that we use when we're using ProDOS. They are, for the most part, pretty much exactly the same as they were in Apple DOS, with the proviso that they've been updated to handle having folders. In other words, they take notice of the prefix that you currently have set. And also some of the commands now have to handle renaming, for instance, folders, deleting folders, things like that. So yeah, obviously the command's been updated. But for the most part, as I've said, they've kept the names the same. We've already talked about cat, giving us a short listing, and then catalog, which is the original catalog name, giving us a longer listing, which is suited to an 80-column display. So that's one change. The next one I would say is, let's talk about formatting. So formatting in Apple DOS involved using the init command. The init command has gone in ProDOS, and now you have to do that using the filer. That's something we'll take a look at later when we actually get around to looking at the filer utility. So that's something which is missing from the command line. Another thing that you can't do is you can't copy files either. That's also been removed. So that's an interesting thing. So let's have a look at doing something which is pretty basic, I suppose, which is how do we create a folder? Well, interestingly, there's no sort of folder specific name. It's just create. So if we go to, let's change to the A disk. So let's go to A and then cat that. There we are. So we have a bunch of folders there. Let's create a folder called fudge. So create fudge. There we go. And if we catalog, you'll see that we have a folder called fudge. There it is. We'll get rid of that later when we use the delete command. So that's how easy it is to actually make a folder. You can just create it using the create command. Now, the next thing we're going to do is we're going to load up a file. That's pretty basic to using DOS. You want to load a file and execute it. So ProDOS has a couple of different variations on the 3 commands that you want to use for that. And it's exactly the same, really, as in Apple DOS. So the reason why we have, well, we actually have 6 different commands, but there are 3 main commands, but they sort of branch off based on whether you want to load a basic file or a binary file. So the 3 commands that we want to use are load. Obviously, we might want to load a basic file and then run it. You want to save your basic file out to disk, and then you also want to run either of those. So the run command is special because it's different from running a basic command from the prompt once it's loaded, because actually what it does is it loads the file and then runs it. So it's a kind of combination of the standard run command and load command combined together. It's this kind of sugar which has been added to both Apple DOS and ProDOS, and it just makes it easier to load files. So we have some basic files in the cats folder. So let's change to prefix. Oops, let's try typing that correctly. There we are. Get that directory. Okay, so I love cats. So I want to load that. So let's type in load. I love cats. So that's going to load it up. Because I used the load command, it's going to work because it's a basic file. You can see that it says BAS for basic. If it was a binary file, I would have to use bload. I'd also have to know where it was in memory before I could actually run it. And that's outside the scope of this particular video. We're not going to get into sort of loading and saving binaries because this video is more of a sort of basic level, really. And I'm assuming that our users out there are not sort of saving out their own machine code programs. So once that's loaded up, we can list it. There it is in RAM. It's already there. If I type new, that should clear it. So let's list it again. Yeah, it's gone, so I can't run that anymore. So let's do the run command. I love cats. What that will do is that will both load it and run it. So let's do that. There we are. I love cats, don't you? I'll just repeat. So let's just break that. That's actually dropped me out of 80 column mode. So let's go back into 80 column mode. Catalog the disk. There we go. So that shows you how to load a file. As I said, load will actually load it up. Bload will load up a binary file. And then run will load up a file and run it. And brun will load up a binary file and then run it. If we want to save out something to the disk, we would have to have something loaded first. So let's load in I love cats. And then let's list it. There it is. So if you typed in some basic like I've done here, you can then save it to disk just using the save command. Obviously, if you've done something in machine code, it would be bsave. And then I think you also have to put in the memory locations where it goes from until to. So the beginning of memory and the end of memory where your machine code exists. So we're going to save it. So I'm going to call this kitties. Save kitties. Obviously, it's identical to I love cats. We just saved out the same program. if we catalog that, we should now find that we have a kitties file. There we go. So now you know how to load, run, and save. What we're going to do next is we're going to rename some files. This is actually pretty similar to the way it is in Apple DuoDisk. As I said, the big difference is that now it has to take into account that you can rename folders and you can also rename volumes as well, which is an interesting thing. Now, we've got this file here called kitties. So let's just rename that. So rename kitties, that's the name, comma, we use separation, comma separation or delimitation, whichever way you want to say it. And then we're going to call it kit. So let's do that. And if we catalog, we'll see that we have kit. There it is. Okay, so that worked fine. So the next thing we're going to do is we're going to rename the breeds folder here. See breeds. So rename breeds, comma, let's change it to types. There we go. And next, let's have a look at that. That should be types. So we're going to change that back to breeds in a second. There we are. So it's now types. So rename types breeds. There we go. Now what we're going to do is we're going to go back to the root of our drive. And this is the boot disk, so I should just be able to do that. So let's catalog that. There we go. So what we're going to do now is we're going to rename the volume name. Now, obviously, for your own disks, that's trivial, you know, renaming your own volumes, but you probably wouldn't want to do that with a commercial piece of software, which may have been set up to have that volume name as something which is intrinsic to the software, as we discussed earlier. But obviously, for your own usage, you will at some point need to rename your volumes. So rename /A, because it's a volume, we have to use the / first to show it's a volume name, comma, and then / again, and then let's call it C. There we are. Now, I've noticed there's a little bit of a problem when you rename volumes. Even though this is our current volume, it doesn't, you know, change the prefix at the same time. So if I type in prefix now, it'll tell us that our prefix is, oh, it has changed it. Interesting. I tried this earlier and it didn't actually do that. So that's cool. It's actually done that. So if we now catalog the disk, there we are. Okay, so I think what it is, what I may have done earlier is I may have changed the prefix on a disk that wasn't the boot disk. And because of that, it wasn't tracking it, and therefore it didn't update it. I've definitely seen that where, so what I had earlier was I renamed the volume name, and then when I typed in prefix, it was using the old volume name. I hadn't updated. And then when I typed cat, it said it couldn't find the volume, because obviously you just renamed it, so volume A didn't exist anymore. So that's an interesting fine point there, which I didn't encounter earlier when I was trying this out. So there we are. Now we've got volume C. And obviously for our tutorial, we probably just want to go back to having A and B. So let's rename that again. So rename C, comma, A. There we are. And if we type prefix, hopefully it's tracked it again, is it? Yes, it has. There we are. We're back with our volume called volume A. Okay, so what we're going to do now is a little bit of cleanup. We're going to go back into the cats folder. And one thing I should say is that the delete command and the rename command are actually in the filer utilities. And the reason why that's interesting is because filer utilities actually has the ability to use wildcards, which do not work in BASIC. So the reason why that's useful is obviously if you want to delete a large number of files, or if you want to rename a large number of files, it can be easier to load up the filer and do it there because you have these wildcards. So we're in that folder. Yes. We've got kit, so I'm going to delete. There we are. Kit. Great. And now we're going to delete the kittens folder. But before I do that, I want to actually protect it. So I just want to show you the lock and unlock commands. So I'm going to lock the kittens folder. And then we'll do a catalog. And you'll see now that because I've locked it, it's put an asterisk next to it. And that means that it's a protected file. So we're going to now try and delete it. Kittens, there we are. And that's going to fail because the file is locked. Well, it should actually say the folder is locked, but yeah, it is locked. So to get it back to being unprotected, we want to unlock kittens. There we go. And now I'm going to delete. Oops. Actually, this is an interesting thing. I'll remind you of this from the last tutorial on Apple DOS. Where the cursor is and everything after it actually gets omitted when you press enter. So even though I haven't actually deleted those characters there, they don't actually get included in the command line. So let's press enter. And you see that when I pressed enter, all of those extra erroneous characters disappeared. So it's quite easy to do typos on an Apple II. And unfortunately, the delete key doesn't work and you don't have backspace. So it's a bit of a pain in that regards. But it is important to remember that when you have extra characters after where you have the cursor, don't worry about them. They'll disappear when you press enter. And that's the same in the filer utility as well. So there we are. So we can see now that we can delete files, we can delete folders. If we want to stop that happening, we can lock them, lock files and folders. That's an important distinction. Don't think you can lock a volume as far as I'm aware. Should we try that? I'm guessing it won't work. So let's try lock/A. Yeah, it doesn't work. The way you would do that is, and we covered this in the last video, you would actually put a piece of tape over here, over the right notch. This disk is currently one-sided. If it was double-sided, you'd have two knocks. You'd have another one over here, which means you could use the other side. Now, interestingly, the read side is actually the underside. That's where the head is. But when you put some tape on here, you're actually protecting the underside. Don't worry about that. It's not really a big issue. We tend to think when we look at floppy disks that side A is the top side, this magnetic media here. It's actually not. It's the underside. But if we wanted to protect this side of the disk, we would put some tape here. That's effectively locking it. And if we had a knock here, which then allowed you to use the other side, we'd have to put some tape over here to protect the other side. That's the equivalent of locking the disk and protecting it from being deleted. For that reason, right now, the other side of the disk is effectively write protected because this is here. Yeah, we'd have to use a knocker to actually take that out and leave a knock in it. So those are all of the sort of main basic commands. The next thing we're going to do is have a look at the filer. And as I said, there are a number of things which you can only do in the filer, and there are also some commands as well which are enhanced in the filer. So let's do that next. Okay, so let's take a look at the filer utility. There's one thing I'll say before we carry on. This is not going to be an exhaustive tutorial about the filer utility. It does actually have a tutorial built into it. It has a question mark that you can actually get some information. And it's quite a large set of utilities, so it's not really practical in this video to cover absolutely everything. But what I'll do is I'll show you some of the main functionality, and I think that's really all we can really do in this particular video. So to load it up, we have the utilities disk in here. So I'm just going to do print slot number 5, and that's now loading up. We just need to wait for that to load for a second. I think the first thing we're going to do is we're going to format a disk. This disk is actually completely blank. I've never used it. And I'll prove that to you in a second. There we are, it's loaded up. So let's have a quick look at the main menu. As I said, you've got question mark, and pretty much every sub-menu in this has a question mark, so it allows you to understand exactly what can be done. Also, another option, if you want to learn about this utility in detail, is to go online and get the PDF, which is the manual for this as well. So we have ProDOS filer, that's the main utility suite. DOS to ProDOS conversion. So if you've got an Apple DOS disk and you want to turn it into a ProDOS disk, there's the utility for you there. display slot assignments. So that will actually show you what you have in the physical slots here in the machine, not the same as volumes. Display and set the time. If you had an Apple II with a real-time card with a battery in it, you could actually then set the time and that would be consistent. Not really that useful these days because obviously most people aren't going to be doing any real work on an Apple II. But back in the day, that was a major feature, being able to actually set your time and then have your files dated appropriately. And then B is basically to drop back into AppleSoft Basic. So we need to press F to load up the filer utilities. So it's going to do that. And in the filer utilities, you have a number of utils, but you have two main branches. You have files and volumes. So you've got, again, the question mark for tutor, so you can learn what you're doing here. File commands, so individual files, and then volume commands, and then configuration defaults. Let's have a quick look at configuration defaults. So select the defaults, S. So it's interesting that you can actually set your source drive. So for instance, you could have this drive here, and then you could actually set your target as being this drive here. So everything by default will be like that. In this case, we're just going to leave it as it is. So I'm going to press escape and escape again. So we need to do a volume command, and that is because we want to create a new volume. So let's go to V for volume. And we've got format a volume, copy a volume, list volumes. List volumes is quite interesting because let's do that. And it's just going to check the drives and check what the volumes are. And you can see that in slot 6.1, which is this drive here, you've got volume A. In this here, which is 6.2, we've got volume B. In 5.1, we've got ProDOS, which is this disk here. And interestingly, we actually do have a RAM disk as well, which is in slot 3, device number 2. So it's interesting. It looks like slot 3, device number 1 is the 80-column card, and device number 2 is the RAM expansion. So that's quite interesting. So I've tried it out, and you can actually copy files into the RAM file, into the RAM folder. You just use that as the volume name. So if you had a machine with even more RAM, you could actually, when you boot up the machine, actually put some stuff into RAM and then run stuff from there if you wanted to. Again, this was a bit of a killer feature back in the day and is one of the new features of ProDOS. I just thought I'd show you that. So let's get out of here. Let's pop this disk into slot 6.1. What I'll do now is I'll show you the volumes again. Let's list the volumes again. And you can see it's trying to access the volume on here, but it can't because it's not formatted. So now we're missing slot 6.1. It's not there. We don't have any volume for it. So let's do that. So let's create format a volume. And we want to go for 6.1. And the volume name is going to be new volume. There we are. And off it goes. And it will now format that disk. Quite exciting there. Bit of a head reset. This will obviously take a while, so we're not going to look at this in real time. So I'll just let this go through the formatting procedure, and then we'll carry on. We'll take this out actually when it's finished, and we'll put this back in, and then we'll carry on. There we go. Actually quite fast actually. So let's escape out of here, list the volumes again, and now we should find that we have a new volume in 6.1. There we are, 6.1, new volume. So that is actually now formatted. Great. Let's put our ProDOS A disk back in again. And quit out of here. So yeah, we have a utility here for copying a volume. We're not going to do that. Rename a volume, we saw how to do that earlier in BASIC, but you have a utility here to do exactly the same thing. If you have a disk which has problems with its blocks, in other words, it's showing errors, you can detect what the bad blocks are there. This shows the block allocation, etc., etc. Compare volumes, that does, I guess, a block by block comparison between two different volumes, either in the same drive or I guess in two different drives. So those are the volume commands. Let's escape out of here and go to the file commands. So F for file. So you've got list a ProDOS directory, which is very similar to, I guess, setting a prefix and then cataloging at the same time. So let's try that. So L for list. So let's do a cats. Yeah, and it's just going to go into the cats folder and tell us that that's what we have in there. Now, interestingly, when I did that, I didn't really sort of set any sort of prefix. So to do that, you've got to set prefix down there. That's quite useful actually. So let's do that, P for set prefix. And we're going to work in the cats folder. And you can see that it actually was set to being ProDOS, this disk here by default. So let's set that as our prefix. And what I'm going to do now is let's rename some files. You've got rename some files here. So let's list that directory again. Now, interestingly, once you've set a prefix, I don't think you can list by just typing nothing. So let's try that. List. Let's try that. Nope. Let's try nothing. Nope. So I'm not really sure what you're meant to do because we're now actually in the cats directory. So how do we just list in the cats directory? I'm not really sure how you can do that. But anyway, I think we can just type in a cats again. There we are. So what we're going to do is we're going to rename cat 1, 2, 3, and 4, and we're going to call them bat, let's say. For that, we're going to make use of wildcards. So let's click on R. We don't have to type in the path to cats because we're already in there. So I'm going to type in cat and then equals, which is the equivalent of an asterisk in something like DOS or Unix, Linux. Now, what's interesting is that you have to use the same prefix in the target name as well. You can't just do it there. So that's slightly different. So if I press enter and then bat and then equals as well, we'll do that. And it's going to go through each file and rename it. And it's telling you there that it's renamed cat1 to bat1, so on and so forth. There we are. So if we list that directory again, there we are. So they are now called bat1, 2, 3, 4. So let's rename it back to cats. So let's, there's a reason why I want to do this. So bat. This time I'm going to use question mark. And the reason for this is that, especially when you're deleting, you may want to have confirmation that you want to do that action on a single file. Obviously, with a wildcard, it can be very greedy and it could end up, deleting files that you don't want it to do that. So that's the other wildcard. You can do question mark. So let's say bat and then cat. And again, we have to use the same wildcard here. Otherwise, it will complain that there's a mismatch. In fact, let's do that. Let's just do cat equals. There we are. It says the wildcard use is inconsistent. So if we do question mark, it's okay. Carry on. And now, as it says, for each file, you have to say yes or no. So bat1, yeah, let's rename that. Yes. 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 Great. Okay, so let's just list the files again. L for list. As you can see now, they are back to being cat 1, 2, 3, 4. So let's say we wanted to protect these. Let's alter the write protection. And the path we want to use is cat equals. Lock the files, yes. Now it's actually locking those files. This is really useful because, if you have a large number of files and they, are easily matchable using wildcards, that's really useful that you can actually lock them that way. If we list that directory now, you'll see that we've locked all of our cat files. So now let's say we wanted to delete them. We can say cat equals, and it will now try and delete them. And as you can see, it couldn't do that because they're locked. So that's obviously pretty cool that you can do that. So let's alter the write protection again. Cat equals no, we want to, that's quite interesting. It's not asking us, do we want to unlock them? It's saying, do we want to lock them? So in this case, I guess we want to say no to unlock them. There we are. So it's unlocking the files. And let's do a quick list again. There we are. So what we're going to do now is we're going to clean up those files and we're actually going to delete them. So D for delete, and it's cat. And because it's a delete operation, I would probably always go for the question mark. So let's do that. And we're going to say yes, 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 and yes. Let's list the folder. There we go. So we got rid of all of those files. We could also, let's go back up a level actually, and let me just quickly check here. So let's just see if there's anything else we would want to do here. Oh yeah, before we finish, let's quickly copy a file actually. So let's list the directory. So L cats. You've got a file there, I love cats. Let's copy that. So escape that. Let's copy. So you need the path name. We're already in this folder, so I love cats. And I'm going to write it to a file called cat. Can you imagine what I'm going to call it? Cat1. Let's call it cat1. And off it goes. Takes a short while. What's quite nice is once it's finished, you're left still in the utility. So you can then cursor forward. Don't press return there because it will actually get rid of everything along the line. So go to the end of the line like that, press enter. Again, go to here. I'm going to click on that. And now I'm going to copy the same file to cat2. So that's quite nice about the copy utility. Also, you can use wildcards as well. So that's quite cool. I wonder if there's anything else we missed out here. Copy files, delete files, compare files. We haven't really got any need for that right now. Alter-write protection, we've seen that. We've seen renaming files. Make a directory. Let's make a directory. New dir. Let's call it that. There we are. And if we list, there it is. There's our new directory. We'll just delete that. There we go. And let's now, let's just do a list again. There we are, nice and clean. We got rid of that directory. And I think what we'll do is we'll go back up to the volume commands and we will rename a volume R. So in the volume in slot 6, drive 1, yes. So let's call it kitties. Carrying on with the cat theme again. There we are, rename complete. Now if we list our volumes, it should say that slot 161 is kitties. It is, so we've renamed that. So let's just rename it back. 6, 1, and A. Remember, we don't have to get rid of all those characters. If we press enter, everything after and including the cursor will be just omitted. There we are. So A is done. And then if we list our volumes again with L, we should find that 6.1 is back to being A again. So there we are. Those are the filer utilities. Like I said, I'm not really going to go into every single feature of it. It's not really meant to be an exhaustive tutorial, but I did want to show you how to use the wildcards and how to use it in general. I didn't know when I started using this that you can actually omit things after the cursor, which meant sometimes I found I couldn't rename things. That really foxed me. So thanks to whoever it was out there in the community who said that you can do that, you know, everything after the cursor. That must be a standard basic thing, which I just, because I didn't grow up with the Apple II, I didn't learn that back in the day, that everything after the cursor just gets omitted. The other thing as well is the way that the wildcards work is a little bit different from MS-DOS, for instance, or Linux or something like that. And the other thing that I found interesting was that if you try and use those in the basic command line, they do not work. They do not exist there. They only exist inside the volumes. So yeah, interesting that, you know, copy, unlock, and rename are more powerful really inside the filer utility. Although obviously you can rename things, lock and unlock. In the command line, you can't actually copy anything. You have to do it here. So yeah, those are the filer utilities. So there we go. That was our tour of the UniDisk 5¼ drive and also ProDOS, the upgrade to DOS for the Apple II system that came around in the early 80s. And I must say it was a really big upgrade to the capabilities of the Apple II. The ability to have subdirectories was obviously a massive boon. And having volumes as well, being able to navigate to files using a directory structure which navigated directly from the top level from the actual volume name of the disk made a big difference to obviously developing commercial software. I think one of the biggest things that it did, and we haven't really talked about it in this video, is allowed for the practical use of hard drives. Obviously, we discussed that in our timeline video, that a hard disk solution, the Corvus 11A, came out in 1979. And obviously, as those eased into the market, the need for a hard disk on an Apple II would have become bigger and bigger. Now, you've got to bear in mind that the only people really using hard drives at that point were really people doing businesses, because they were a very large investment to get one of those. But it's also important to remember that at this point in time, I'm talking about 1979, the IBM PC hadn't come out. So at that time, the Apple II really was quite a big player in the sort of home and small business market. So the fact that they didn't have a very usable DOS to use on hard drives obviously was a bit of a problem to making full use of an Apple II in a business environment. So as we saw, ProDOS fixed a lot of those problems. If you've used another computer, for instance, I was more familiar with the Commodore 64. My first disk drive was actually a 1541. And in that drive, it had a different solution, which I thought was quite interesting, that the 1541 had all of the DOS commands built into it on a ROM. And then that was communicated to the Commodore 64. So what that meant was as soon as you plugged that drive in and turned the machine on, the DOS commands were there available for you to use. You didn't actually have to load anything off disk. And to be fair to the Apple II, even though it did have to load its DOS into RAM from a floppy disk, once it was there, it was actually very capable. So I find it really interesting that, you have these different solutions from different people, and they have their pros and cons, swings and roundabouts, whichever way you want to put it. The Commodore 64 solution had the benefit of not using up any extra RAM, because all of those commands were, built into the ROM on the drive, and that was fantastic. Unfortunately, Commodore completely fluffed it up in every other way with that drive because of the way it evolved, and it ended up having just terribly slow performance. And the other thing is as well on the Commodore 64 is it has, quite weird commands. Some of the commands for doing quite basic things, like for instance, formatting a disk, are terribly esoteric, incredibly complex. And ProDOS generally has quite easy to remember commands, as we saw with Apple DOS, which it inherited a lot of ideas from that platform. Something I found quite tricky with ProDOS was the prefix system. Obviously, I'm used to MS-DOS initially. I think that was the first. Actually, no, I don't think it was the first DOS that I used. I think the first DOS that I used was Amiga DOS. And that was quite a sophisticated DOS, to be fair. And that was only, 1986, something like that, only a couple of years later. And then later in the 90s, I then encountered MS-DOS. And then later, I used Linux quite a lot in the late 90s and especially during the 2000s, because I used to work in visual effects, and that's very much based on using Linux. So I'm just used to, changing directory and not having to use the term prefix. It's quite a long term to have to keep on typing all the time. And it's just interesting the way that, different disk operating systems handle changing directory and remembering where you are. In Linux, you have PWD that shows you your location. Obviously, with ProDOS, we have prefix, and then you change the prefix with that. So it takes a bit of getting used to. I find it quite weird the way that the wildcards don't work in the command line. But that's, I think, to do with the fact that it has to load everything into RAM. So I think the development team at Apple were mindful of the fact that they shouldn't put too much into the DOS, because it would just basically gobble up all of your RAM, and you wouldn't have any memory left to do anything else. So yeah, it wouldn't be that useful a disk operating system if it just took up all your RAM. So there's obviously a trade-off going on there. I really enjoyed learning how to use ProDOS, and it's put me in a good stead for using my Apple II in the future. I must admit, for quite a long time, I've been a bit of an Apple II numpty, really. I didn't really know how to use it. So now I feel a lot more confident about using Apple DOS and ProDOS. And in the future, I probably will actually refer to my own video to remember how to do some of the more specific things, some of the syntax. So if I don't use my Apple II for a while, because I have a number of different machines in my collection, then this video and this series will actually be just as useful a reference for me as I hope it's becoming for you out there, sort of newcomers to the Apple II platform. And hopefully it's interesting to people who've used Apple IIs for years. Anyway, quite a long video. Obviously, we had a lot to fit in. I hope you enjoyed it. And if you did, then please click on the like button. And if you've only come here for the first time or you're not subscribed, then please make sure you click on subscribe as well and hit the bell. The bell will give you a notification about any other videos coming out in this series in the future. I hope you enjoyed this video and hope to see you back for the next one, where we're going to be looking at hard disk solutions. So that's going to be pretty interesting. I'm talking about SCSI cards and also a booty. And I have another card which was donated to the channel very kindly. Haven't used that yet, but I believe that can be set up as a hard drive solution as well. So it's mainly going to be looking at modern solutions, although the SCSI card is a real SCSI card from Apple back in the 1980s. But for that particular card, I'm actually going to be using a BlueSky because I don't really want to use a physical hard drive anymore. I'm not really hung up on that. And the reason for that is I just had so many old hard drives die mid-use, and so it's a bit of a pain. I do love the sound of them though. I do love the whining spin up on them, but they're just so fragile these days, those old hard drives. But I think to get the most out of my Apple II, I need to use a hard drive solution, so that's what we're going to look at next. I hope to see you then, but until then, take care and good day.